What's up guys, this is Josh the Gamer here coming at you with a brand new video, and in this video we are going to be continuing on with our Quorum game development series, and in this installment of the series we are going to be learning about velocity. Now, what is velocity? Well, velocity is basically the movement of an object, like how fast it's moving and so on. There are two different types of velocity. There's linear velocity, meaning moving in a straight line or diagonal line or whatever and not turning. And then there is angular velocity. Okay, so angular velocity basically means how fast an object is spinning. All right, so it's very, very simple. But first, before we learn about the different types of velocity, we need to quickly go over three-dimensional vectors. Now, I know I've gone over two-dimensional vectors before, and I think I've gone over vectors in general before, but it doesn't hurt to go back over them. So, a three-dimensional vector is a type of vector that has an x, y, and a z or a z coordinate, depending on where in the world you are. And those will basically be used for calculating the different things for linear and angular velocity. Excuse me, guys. Alright, so let's go ahead and get started. Now, the first thing that we need to do when we have our when we need to do some angular and linear velocity stuff, we need to create a few vectors. But before we do, we have a very basic template here. We have the same code that we wrote in the last tutorial, the tutorial on gravity, if you remember that. So that's what it does. Just a cylinder falling from the sky and hitting a box. Simple. So let's go ahead and create some vectors, but first we need to import them. We need to import the 3D vectors. So inside of our use statements here, we're going to go ahead and do use libraries dot compute dot vector3. If we were working with 2D vectors, we would be doing vector 2D. Or vector 2. Oh, excuse me. Okay. With that being said, let's go ahead now and go inside of our create game action. Above our enable physics 3D, actually no, we're going to go ahead and put our vectors where all of our objects are declared at, specifically our model objects. So, underneath our model objects, we're going to go ahead and declare a couple, or one rather. We're going to declare a couple vector 3s. Go ahead and do vector 3. Just type vector 3 with a capital V. Okay. Then with that, go ahead and we're going to name it velocity lin for linear velocity. Now, inside of our create game, we're going to go underneath our enable physics 3D. And we are going to set the values of the vectors, or the vector for linear velocity. So type velocity lin, or whatever it is that you named your vector, colon, and then we're going to call the set. Now, as you can see, there's many different options here. We can set 0, we can set the X, Y, and Z manually, do separate actions, or we can just input the values into a set method with the X value, Y value, and Z value as parameters. We can also set the values using a vector 2 and a number, an array of numbers, or a vector 3. Specifically, we want this one, the set number X value, number Y value, and number Z value. So go ahead and now we're going to put parentheses around that. We're going to pass it 3 different values, the X, Y, and the Z. Now, let's say we want this to move off of the platform away from us. So we want it to move and then fall off the platform. Well, that's actually very easy because we are going to go ahead and do 0 on the X because we don't want it to move on the X. We don't want it to move on the Y either, so we can just go and do a 0 on the Y. Now for the Z, that's going to be something to think about here because we want it to move on the Z axis. Because we want it to move away from us. And the further positive the number is, that should make it go away from us. Negative goes towards us. Unless it's the other way around. Gotta remember, we are using the left hand coordinate system. So we're going to think about this here. The left hand coordinate system, wherever the direction your fingers are pointing to is where positive is. So yes, away from us is positive. And then towards us is negative. So we're going to say 1 meter per second. Because this is measured in meters per second. So, now that we have that set, we now need to go all the way down to where we have our cylinder. And we need to do this underneath the enable physics action call. Why? Because these types of actions, can only be called when physics is enabled on the object. If we call it when physics isn't enabled on an object, then it's going to spit out an error. So we're going to go underneath the responsive states. And we don't want the ground to have any kind of force because it can't respond to it. So cylinder colon, and we're going to say set linear velocity. All right. So now we have that. Now that we have that, we can see that there are 4 different options here. There's one where we can pass in a vector 3, and then there's set linear velocity x, y, and z. 3 different actions. We can set the x, y, and z as the linear velocity with separate actions, but we're not going to do that. You may want to do that depending on certain circumstances, like if you're doing keyboard input, maybe that would be beneficial to you. But other than that, we need to, right now we're going to do the set linear velocity vector 3 linear velocity. And then now, once we have that typed out, we can just go ahead and pass it the velocity lin, or whatever you named your vector, and we're done. Go ahead and save it, and then we're going to run the game, see what happens. As you can see, it starts moving, and then it falls off the platform. But of course, it moves as it's falling, so that's something to keep in mind. But yeah, that's basically linear velocity in three-dimensional space. Now we're going to go ahead and do we're going to do angular velocity. So go ahead up here into your, we're going to go up here into our vector object. We're going to rename this from velocity ln to velocity ang, standing for angular velocity. And then every instance that we use of it, calling set and that kind of thing, go ahead and change it to the new name. Now, just changing the name of our vector isn't going to do anything, because we're still calling the set linear velocity action. But how do we change it? Well, that's actually very easy, because we are going to go ahead and we're going to get rid of the set linear velocity action call, and then we're going to call set angular velocity. Right? We're going to change it to set angular velocity, and we're going to pass velocity ang into it. Alright, so with that done, we can go ahead now, save the game, and run it. As you can see there, it did indeed rotate the object. But if we go and, let's say, if we go up to where we're setting the vector, we can go ahead and we're not going to do it on the Z this time. We are going to do it on the X. We want to say we're going to go ahead and spin this 10 meters per second. So save it and run it. And as you saw there, it was spinning and now it's on its side. We can also do this in the update action. So if we go down to where we have our set angular velocity, we can go ahead and copy that line, delete it into the create game, and then we're going to go into update. We're going to paste that line in there. So now continuously it'll just spin. It'll spin continuously. And there you go. And it's just going to keep doing that forever. It's spinning 10 times per second. It's doing a 10 meter per second spin. It's awesome. And yeah. So that is angular velocity. And now it may be as good of time as any to teach you about torque. Now, what is torque? Well, torque is essentially a push. It's an angular push. So when you're like, a good example of torque would be when you are twisting a bolt with a wrench. That is torque. So let's go ahead and actually do that. We're going to call this in the update action, so you can kind of see torque in action. Because if we do it in create game, it's going to kind of, well, not show it as well. So we're going to go ahead and do : apply torque. Okay, so we then pass it a vector 3, so we're just going to pass it velocity angular. Then we're going to save it and run it again. And now, as you can see there, it's continuously applying a lot of torque every frame, which is causing it to go berserk. So we can go ahead and dial that down a little bit. We're going to set it to about, not 15, that's more. We're going to do 5. And then run the game and see how that does. So there you go. As you can see now, it's kind of slow. It was slower when we initially started it up, but now that it's kind of bouncing around and stuff, it's going to just do its own thing. Because it's physics. Things build up. So yeah, that is basically how that works. It's basically torque. It's an angular push, like when you're screwing in a bolt with a wrench. So that basically does it for this tutorial, guys. Thank you all for watching. In the next tutorial, we're going to be learning about force and restitution.